Hey everybody, my name is Akshay Krishnaswamy and I'm the Chief Architect for Palantir's commercial business. I'm excited to talk to you guys today about the Foundry platform. Just one note on who Palantir is for folks who might not know. We were founded in 2003 with the mission of building data-driven operations and decision-making software. We got our start in intelligence and defense, kind of working across national security contexts, and a lot of how we think about our software was informed by the kind of learnings in those frontline deployment settings. Today, we work across a lot of different industries, 40 plus industries, a lot of places outside of government, and across the commercial sector, in the nonprofit sector, and all parts of the government now as well. We have 3 software platforms at Palantir that we think of as operating systems. Gotham is our operating system for intelligence and defense. Apollo is our operating system for...
Welcome back to the channel, everyone. Today, if you're a non-technical user, this might be the most important video I've ever put out. I had a great conversation with a gentleman on the Discord server the other day just about the complexity, the inherent complexity in orchestrating like an open source big data engineering stack. And what I want to get into today is why that is always an inherently risky endeavor. And B, I want you to meet your competition, which is the chief architect at Palantir. If you are going to go to your company and decide you want to build a big data engineering software system, you're directly competing with this man right here and his ability and his innate understanding in the harshest environments imaginable of how to build software that delivers business value. So get ready, people. The first part of this, we're going to go through a presentation I give at work. We're going to talk about some takeaways. And then I'm going to leave you with this gentleman right here to explain why Foundry is the future. All right, welcome back to the channel, everyone. Today I want to give a presentation that I give at work because I think it'll help really dovetail into a conversation I had on the Discord the other day, which was a really positive conversation. And I want to keep that momentum going because I want people to it really encapsulates the state of play for Foundry right now and for Palantir when they're battling the idea that, a lot of engineers want to build their own, big data engineering platform on open source technology. So with that said, let's dive into this presentation. And this is for non-technical folks. There's some technical elements, but this is a presentation I give to stakeholders. So like CEOs, CTOs, chief marketing officers, everyone who's a key stakeholder at the business basically gets a copy of this presentation. So let's go for it. Startups are risky business, right? We all know this anecdotally. And basically all startups fail, right? So like across all industries, the startup failure rate is 70%. And in technology, that's higher. The startup failure rate is 90%, right? And most of them fail within 2 to 5 years, the vast majority failing within 2 to 5 years. And what are the reasons for this, right? So the contributing factors to failure, funding. Do you have enough capital to actually achieve your goals? And what about timing, right? If you were launching a company during the COVID pandemic, might not have been a great time to launch your company, depending on what business you were in. People, the first 200 hires at a company can kind of make or break you. And if you don't develop the right hiring pipelines and culture, your business is going to implode, So insight, what is your secret, Peter Thiel talks about this a lot. And these are, if you've read Peter Thiel's book, you're seeing where I'm gathering most of these from. What about distribution? Does it cost more to sell your product, than you're going to get in profit from it? So if you can't sell your product effectively, it doesn't matter how good it is. And this has been one point, by the way, that people are bringing up on the Discord, which is great. That Palantir may be violating one of these rules that Peter Thiel laid down in the distribution process. We don't know that, but it is a theory. Durability, do you have staying power? As other competitors enter the market, is your product sticky or your customers going to stay with you? But the one we're going to focus on today is engineering, right? And this should be the one factor, if you're a technology company, that is fully within your control, right? So because it's literally the code you write, And what makes engineering so challenging? Well, in a word, it's risk. Most of what we do in engineering is uncertain. It's arguable that agile software development was created as a means to mitigate risk. And I would argue that the majority of innovation over the last decade has really been focused on reducing the risk in system design. And so the concept of best practice services and frameworks that abstract away undifferentiated heavy lifting is essentially risk management. And so engineering initiatives will live and die by how well you mitigate risk, right? And so let's take a look at what makes up the technology risk vector, right? So it's time to value, total cost of ownership, SLAs and support, complexity and implementation, the talent pool, and training and documentation. And when people ask me, like, how do you evaluate the risk profile of technology, this is what I'm looking at. You know, it's not what people tend to think of when they're considering things like, you know, whether this tool is great or whether this tool is great. It's like when I'm evaluating risk, I'm looking at the IT asset, the thing that actually delivers value for the business. How risky is it for us to maintain that asset and continue delivering that value over time, right? So this is what makes up the risk vector for technology. And so how does risk manifest as failure? And all these items kind of build on each other, right? So like the first thing you tend to notice is that your code is hard to reason about, and the effect that you can't really figure out what's going to happen when you introduce changes. And that leads to the slowdown in the ability to quickly implement changes and new features. And this tends to lead to a problem of the inability to onboard new engineers quickly because your code base is becoming more complicated, more convoluted. You'll start to notice a loss of velocity as you can't, hire around the problem or hire to solve the problem. And then you'll start seeing projects being delivered late and of low quality. And eventually you start seeing canceled projects and total rewrites, right? So this is how risk will manifest itself as failure. And let's look at some examples of risky code out there in the wild. And the boilerplate bottleneck that I'm referring to here is essentially like 15 ways to solve the same problem that you often see across teams, right? So like they've all got their own boilerplate, they're all solving problems in different ways, and this leads to really complex implementation. It's hard to hire people around, and as a result, your talent pool shrinks. The documentation is super time intensive because you have to document every way in which a team solved the same basic problem. This is why I value frameworks so much and why I value technology platforms that solve an entire category of problems rather than looking at one-off solutions across every single team. The other one we see often is what we call the wrong abstraction, and Dan Abramoff from Facebook gave a great talk on the wrong abstraction. If I can find a link, I'll leave it in the description. But basically, the wrong abstraction essentially is like when developers want to keep their code dry, which means do not repeat yourself. So they try to create these abstraction libraries that bundle up all bits of reusable functionality. But as you can imagine, every time you do that, you create a system that's harder and harder to reason about because it's this convoluted matrix of abstractions in which it's very difficult, unless you actually wrote it, to know what the code is doing. And so we often advocate for what we call wet code, and we do repeat ourselves if it leads to a cleaner code base that's easier to reason about and train people on. So this is something that if you're not in the industry, you might not know about, but this is another example of risky code. And then there's the Black Box Maximul, right? So if you build a black box, and so like a black box is software someone hands you that should just work. It may or may not have well documented public APIs. It may or may not be well built. It may or may not be maintainable. You kind of get the point here. And black boxes, by definition, maximize risk because they are complete unknown. And teams often struggle to understand why they can't build black boxes that integrate into the stack. It's essential to move beyond this with one key principle. It's not your code, it's our business, right? Leadership is responsible for maintaining the IT asset over time, and that is simply impossible if teams decide to create black boxes, right? So like, and people, when they say this, they think that is an enterprise problem. It's like, no, if there's an enterprise that actually offers a platform, that's by definition not a black box. It's when your teams internally decide to recreate those platforms and do none of the things that an enterprise decides to do when they offer a product to customers, like providing documentation for one, right? So like, I think it's often overlooked. And this is a good example too of where technologies like Dask and Rapids versus Spark, didn't just immediately take over. Is just that it was at that time, when those technologies were being released, there was no enterprise support. So businesses didn't want their teams going ahead and building these stacks in which they become unmaintainable. All right, so these are some examples. And without risk mitigation, you're gonna fail eventually. It's actual scientific fact. It's a law of engineering. Like, this isn't something I'm making up or something that, I can just get around this. No, it's like a law of engineering. And it's the paradox of software development is the more code we write, the riskier the system becomes. And as complexity grows, our ability to reason about the system is gonna decrease, right? And good risk management does three things. It keeps things simple, it uses proven design patterns to solve problems, and it includes three things: automation, automation, and automation. But don't take my word for it, right? Like, I don't want you just believing this because this is what I'm saying. Let's take a look at some OGs that have, are responsible for passing on a lot of knowledge to people like me, not directly, but through, capturing in computer science courses and all of the knowledge that we're tapping into. And Lehman's laws of software Lehman's laws of software evolution, they describe a balance between forces driving new developments on one hand and forces that slow down progress on the other. Now, if you're a developer, we all know that developers know this anecdotally. The more code you add, the harder it becomes to add more code. And it's a really strange paradox, but it is a law of software engineering. And great minds think alike. Roger S. Pressman, he noted that he wrote this little 100-line program with some nested paths, and a single loop executing less than 20 times may require 10 to the power of 14 possible paths to be executed. You are not going to test your way out of complexity. Testing, that would be 100 trillion paths and would take over 3,000 years to fully execute. That's off a simple 100-line program. And that's because computer systems are complex, man. It's insane how complex, hence the risk. So you aren't going to test your way out of this problem. You're not going to get around this problem. And that brings me to what I think is the answer. And this OG here, Rich Hickey, I'm going to read this quote because I think everyone should hear this quote at least once in their life. Simplicity is hard work, but there's a huge payoff. The person who has a genuinely simpler system, a system made out of genuinely simpler parts, is going to be able to affect the greatest change with the least amount of work. He's going to kick your ass. He's going to spend more time simplifying things up front, and in the long haul, he's going to wipe the plate with you because he'll have the ability to change things when you're struggling to push elephants around. 100% right. Our systems need to be simpler so we can get around this one. So keeping things simple is really the key, in my opinion, to how we mitigate risk and how we can lower the risk profile of IT assets, right? So how do you do that? Okay, well, one of the things we do at work is we don't let people reinvent the wheel. So like if there is a framework like React, right, that solves how do you build a web application UI and how do you do it in a clean way that developers like, we adopt that tool. We don't let people create custom frameworks, okay? And if there is a platform that solves an entire category of problems, we adopt that platform rather than build black boxes on open source tech in which the problem space isn't fully solved. So, and that includes things like, so when you're looking at these open source stacks that essentially people are piecemealing together to emulate something like Foundry, there's a massive risk baked into that, which is that you have not solved, one, it's that you haven't solved all of the problems in that space. You've only tackled a handful that delivered on one immediate use case, not considering all of the downstream problems related to that when this thing becomes an IT asset that the business relies on to generate revenue. The other problem with that is that just orchestrating distributed systems is fucking hard. And most of the time developers completely underestimate the amount of complexity in there because they haven't been doing this shit that long. Like, look, guys, the first 10 years of being a software developer, that just determines whether or not you're interested. The following subsequent 10 years is where you actually learn how to do shit that's meaningful for a company. And you start to understand these lessons that you're going to learn over time. And once you've had a 20-year career, at that point, you're probably qualified to make like real business decisions regarding IT assets and how they're built and maintained, what the risk is, and communicate that to investors who are relying on you to not fuck up and waste their money. So, in my opinion, trying to orchestrate all these tools to build platforms in a solved space is saying to the business, we're going to be in the data engineering software business. I don't want to be in that business. I've got another business over here to run. I don't want to be in the data engineering software business because your 5 or 10 person team is never going to fully solve that problem. There are entire companies like Databricks and Palantir dedicated to that problem. And 2, it's going to be a massive risk if you fuck up even just a little bit for all of the downstream work that's going to rely on that work product. So keeping your system simple is the key to success. So what's the big deal? Why is this so important? Why am I saying this might be the most important video you ever watch? Because it fully encapsulates the state of play right now. Why Palantir is in the position it is, why people are struggling with adoption, why people like myself see Foundry as a godsend while others see it as problematic or disruptive or a emulation of some other set of tools that we use, which is absolutely not the case. Foundry fully solves the problem space. And I think if people can really wrap their brain around this idea that what people who are really concerned about propelling a business forward. They're worried about risk mitigation and the complexity of their stack. That's a fundamentally different way in which people look at problems than, say, a software engineer who wants to build a stack. We just see the world fundamentally differently. We're trying to solve different problems. I'm more focused on trying to make sure that we deliver on our growth goals and our revenue numbers, and that we build systems that are maintainable and can actually springboard us forward rather than be like, a bag of cement holding you down. And engineers will look at that problem and they'll say, hey, look at all these great tools, and I'm going to go build a Rube Goldberg machine over here because it's free and it's cheap and it's easy, but like, it's not free and it's not cheap and it's not easy. So it's interesting how two people can look at a problem and see fundamentally different things. And I think if you start to realize that, if you start to see this like paradigm shift between, people who are looking to accelerate growth and people who are to really need to like deliver on investor expectations and how they might see a product like Foundry versus other people who are in the engineering space and how they perceive a platform like Foundry. And with that, I want to leave you with your competition right here if you're deciding to build your stacks and why Foundry is the future.
Through reports or dashboards. And while there's nothing inherently wrong with reports or dashboards, it does leave a lot on the table when it comes to, well, how do I benefit from people learning what to do when they actually see that data? How do I understand what actions to take as a consequence of presenting that data to business users? And how do we actually engineer a feedback loop between people on the front lines and people in the back office actually doing data and analytics work? You sort of see data coming together in reports or dashboards. You might notice an insight, but then as a business user or an operational user, you just kind of pivot away to the next thing you have to do. And we think that while this is kind of sufficient, this model, this assembly line for reporting and for dashboards, most organizations that we talk to feel the need to go beyond this model, just given the complexity in the world. And so you're kind of limited by this producer-consumer paradigm. And I think, if we think about what's happening in the world today, kind of both in terms of exogenous shocks out there in the world, the complexities inside organizations' four walls with their partners, just having this assembly line approach isn't sufficient for dealing with that complexity. And so what we see kind of over and over again is that folks want to be able to use kind of the exhaust, the learnings, the feedback from people interacting with data and models to better inform their processes. They want to, kind of consider those learnings not exhaust, but fuel for the business. And so we think about, well, how do we kind of turn this typical producer-consumer paradigm on its head and actually kind of have a different modality where there are data kind of producers and consumers in every part of the business working together in a common platform. So we think about Foundry as providing an open architecture for closing the loop between operations and analytics. It provides the ability to bring your existing data and model tooling together inside of an ontology, which you can then use to build workflows, applications, and actually capture decisions with to inform better operations over time and continuous learning. With Foundry, we kind of say to kind of everybody in the enterprise, to data teams, bring your data lakes, bring your data warehouses, bring kind of all the data that exists across different systems and connect that into Foundry as sort of what we think of as the nouns of the enterprise, right? The semantics. And to the analytics teams, we say the same thing. Bring the models, bring the linear programming models, the ML models, the stored procedures, and allow those to be connected into the same foundation as sort of the verbs that go along with the nouns that give you kind of all the business processes. And we think if you can then kind of assemble this operating layer iteratively over time through use cases, you then build out a very powerful foundation to do many things. You can drive more and more kind of operational workflows that are read-write, where business users are contributing their knowledge back into the foundation. You can do kind of more sophisticated analytics, like running scenarios and what-if analysis. And critically, you can capture decisions and pipe those to all sorts of different enterprise systems, both new and old. So again, we think by closing the loop, it's a very different architecture than kind of the one-way assembly line of data. In terms of how it works, Foundry comes with everything you need from top to bottom to implement complex operational workflows. This includes data integration, model integration, an ontology layer that encompasses objects and relationships and actions and business processes, an entire workflow layer that includes application building, self-serve analytics, and more, and a decision orchestration layer that's designed to capture learnings from end users and actually then feed those back to analytics and data teams and other business systems. And so for fresh architectures, we think Foundry can get folks operational in days. But we also understand that most organizations have made investments in existing data and analytics tools. And so Foundry's modular architecture allows you to bring your own data platforms, data lakes, data warehouses, analytics tools, ML services, and plug those into Foundry's data integration and model integration layers, and extend them up into the ontology and into operational workflows. And so Foundry is designed to work in heterogeneous, complex architectures that are changing over time, all the time. One of the most common integration patterns we get asked about is, how does Foundry work with my existing data platforms? My Snowflake, my GCP, my Azure, my AWS data warehouse. And Foundry can be deployed in a mode that is purely extending those platforms into operations, where Foundry will never fracture the source of truth that exists in those data platforms, and instead will marry them up with different analytics tools and business processes to build the ontology in a way that respects the governance policies in place in those analytics and data tools. And so you can think about this as setting retention policies, security policies, and bidirectional data syncs that will ensure that Foundry is always in sync with those existing data systems. As organizations evolve, we expect they're going to continue to invest in new data tools, new analytics tools, new governance tools, and we've designed Foundry to make sure that it can be a great citizen in a landscape that's only going to get more and more complex over time. As underlying data and analytics architectures continue to evolve, Foundry is designed to serve as a resilient, stable operating layer that can continuously benefit from different systems coming online and allow different user groups to make better decisions over time using the ontology-driven approach. So in summary, Foundry is designed to deeply integrate with existing architectures, data platforms, data lakes, data warehouses, and all manner of analytics solutions as well, integrating both data and analytics primitives into an operating layer that can be used to power feedback-driven workflows across the entire business. You can get started today with a single workflow in Foundry, but the power of Foundry is really in the compounding that occurs when you scale from a single workflow to enterprise use cases that span the entire organization. We're excited to see what you're going to be able to do with Foundry.